Are you ready for the second act? All right, great to see you. I've been told to speak English for the second part, I guess because there's some English speakers also following us, so I wish I could also stick to my normal dialect, which I've kept really well, but you'll have to hear my English accent this time. I'm Christina, I work with StartupLab, I'm head of corporate partnerships, and I'm super happy to have you all here and that you hosted this network event with us. And we are here to discuss some of the future solutions for the energy sector, and I'm excited to welcome soon some of the most innovative companies on stage. But first, I'd like to take a little bit of time to talk to you about open innovation and why also collaboration with startups can be part of the solution. So I guess today you have set a really good stage for the problem to be solved, and you all face it in different aspects in different organizations. I noticed that Microsoft also is investing into nuclear, which was mentioned here, so that's exciting. And the demand for electricity and grid capacity is, of course, increasing. So then I'll give you a couple of examples of startup and corporate collaboration, how it can drive innovation. I guess you recognize this, the spaceship test flight number, I think 5 in October, where they managed to land this booster down. It was approaching Earth at a speed of, I think, supersonic first, and then, of course, slower and slower, and then captured by these chopsticks. And this thing is the size of, I don't know, Oslo Rådhus, I believe. So how impressive is that? Very. So this is how SpaceX, partnering with NASA, a large government organization, managed to drive innovation by challenging how a large corporate or public organization was working. You know, very quick innovation cycles, challenging how things were done, experimenting, failing fast, expensive failures when these rockets crash, but still, it worked, right? So soon we are a spacefaring civilization. Another example, a little bit closer to home, which I guess many of you know, is a startup that when I came here 2 years ago, it was in a room, like 6 square meter room, and the room was so packed with hardware and with people that you couldn't see the floor. And not long after, they moved out, and now they're scaling really fast in the US and also in some Norwegian grid companies where they put this neuron onto the grid, where you can also increase the capacity of the network by more than, I think, 40%. At least that's the case I saw. Maybe it's better now, because they keep improving. So another excellent example of how real-time data can unlock more capacity and untapped energy potential in the grid. So why open innovation? Does it need more explanation? I don't know. But having worked more than 10 years in corporate or in management consulting, I know the culture of corporates is different from startups, a little bit more risk-averse for natural reasons, bigger organizations, more bureaucracy, slower decision-making for good reasons, while a startup mentality is taking more risk, moving faster, because the startup is innovative by definition. If not, the startup will die. So there's plenty of research also supporting why working with startups and tapping into that innovative force is a good idea. And here's an example from, well, there's many corporates looking at this, but this example is from Equinor, who I know is here today, public figures. But if you look at venture capital flowing into the most promising startups as part of your external R&D budget, look how much more you can get for your innovation efforts. Equinor is spending, or in 2023, they spent $600 million on R&D. Yet, they found that there were more than 10 times as much funding flowing into relevant energy-related startups. So it makes perfect sense to tap into that innovation as well. That's why we have incubators such as StartupLab. And what do? We're here for the founders. We have an incubator where we accept 10% of the applicants. There's one new startup moving in here every week, one moving out. We help them scale. We also have some accelerator programs that we run also together with corporate partners. And we invest. So we screen about 1,000 startups a year and invest into 2025, pre-seed, seed. so very early phase, which means we know these startups, we work with them side to side every day and follow them over time, which is different than an online database with a lot of startups, which many players have today. And also with new technologies such as Gen AI, you can always scout and scrape the net. So finding thousands of startups, that's no longer an asset. We also have a corporate partner program. These are our current corporate partners. And with them, we do a lot of different things. So basically, it's everything from tech scouting, introductions, how to work with the startups, how to succeed with the implementation, training and innovation and scaling help, not only for the startup collaboration, but also for your own internal innovation efforts or projects, and much more. We have some industry programs. I'll skip that, but I can mention that StartupLab Energi, it's a very thriving program where we connect industry players such as yourselves with startups, with research, with universities to help scale the startups and help scale the innovations and drive results. So we keep the overview. There's so many startups scaling in this space, and there's a lot of money flowing into it, although it's a little bit slower with the current economic situation, but that will pick up again. And we also see a lot of value being created in these collaborations, together with big players like yourselves. We've been partnering with Equinor, who's here today, Statkraft, Hafslund, Eidsiva for some time, and recently also we're happy that Vardar, who's here, and Østfold Energi has joined, and also Statnett. I wasn't here for the Statnett speech, but I guess it was mentioned that they're also trying to do more together with early phase companies. So with that, I'll finish up with the video, because we do 50 events a year. And if you want to know more, you can check our website and join some, and also join the Energy Industry Program if you want to be invited to those events. But here's a little flavor from one of our Open Innovation Challenges. It's a program called 2030, and this is the summit, where we connect problems from corporates with startups who have the solutions. Let's see if it works.
Investors, large corporates, startups.
So many brilliant minds.
We all have a role.
The climate crisis creates new problems, which needs new solutions.
Innovation is the key to tackle climate crisis. It's all tech. So tech needs to be developed, tech needs to be scaled.
And the only people who are going to do that fast enough are startups.
Startup is really one of our chances to actually solve climate change.
We can do this.
It was amazing. It's so much fun.
So with that said, let me pass it on to the real heroes of today, the startups. So let's see whose presentation is first. Versiro, Simon.
Hey everyone, my name is Simon, and I'm the CEO and co-founder of Versiro. Before that, I was a researcher at NTNU, and the company spun out from NTNU. When I was a researcher, I was researching how can we integrate more renewable into the power system. And of course, a very huge topic and a very urgent topic. And what we saw in all of our research, the topics that came again and again, all of the challenges were basically related to the two main ones. You get a lot of uncertain production and you got a lot of volatile prices, because when you try to take away a lot of fossil fuels, you also take away a lot of flexibility from the system. And you replace that with things that are not necessarily flexible. And this is challenging because you still need to operate a lot of assets. You still need to balance the grid, as Statnett talked about earlier. And also you increase a lot of risk in how you operate and how you invest. So looking at this from like a higher angle, as a researcher, we like to talk about something called an energy trilemma. So to achieve a fair energy transition, you need affordable, sustainable, and reliable energy. In the last decade, we have seen a huge increase in the maturity of the affordability and sustainability through wind and solar. But the reliability remains a huge challenge. Why? Because a lot of flexible assets are extremely capex heavy. To install batteries is very expensive. But as you also Startnet mentioned, there are other ways to activate flexibility in the system, but we need to know it and how to do it in a smart way. And this is exactly what Versiro Missions was, and was the reason why we span out from the university to basically close the bridge between what we were doing at academia and introduce a lot of new technology fast to the industry. So this is a problem that's already apparent, right? So this is from the Norwegian markets. So if you own a power plant in Norway, in the NO2, this is a day that you have actually experienced, right? And when Startnet said that we need to think about ways to think about flexibility beyond the spot market, she was talking about this market, the day-ahead market. So today, I make a full production plan of what I'm going to do tomorrow. But that means that there is a full day lag between a decision being made and an operation being made, meaning that a lot of stuff happens in between. And this we can see in a different market called the intraday market. So this day that looks super calm and super chill is actually extremely volatile, right? And when we think about Norway, we think about extreme amounts of flexible hydropower. So why do we see all of this variability, right? And it also comes back to, okay, how can we coordinate supply and demand on the system aspect, right? But looking at kind of the micro aspects is just, okay, how can you maximize the value of your flexibility, right? How can you make sure that you adjust your plant as needed in order to be available at these peaks? And the other side of the coin is the inflexible assets, right? The reason why this is happening is that you have a lot of forecast coming into the day-ahead market. And of course, forecast, the only thing that is sure about the forecast is that the forecast is wrong. And then it's a question, how much is it wrong? And then you need to correct it. And how can you connect it in the cheapest way possible? And that's exactly what Versiro is working on. So why is this complex? Because the power market is complex, right? So me as a private person, I only have to care about one price that I get. As the producers, you have to care about tens of prices, right? And then how do you know in which market is your asset the best? At what time should you get into that market and for what price? It's extremely complex, right? And it's still only one commodity, right? There's still energy. So if you go into one market, you also close yourself off to opportunities in other markets. And some of them are for capacity, right? Standing idle, and other ones are for actual production, right? So it's just extremely complicated. And once you do one decision, kind of this feedback loop goes up, and you need to make basically decisions all the time, right? And this is where Versiro comes in. So what we do on like a high level is that we use basically AI technology to quantify the uncertainty in all of these different markets, right? And for those who are economists, you know, once we can quantify uncertainty, we can calculate risk, right? And once we can calculate risk, we can take a risk-adjusted optimal position in whatever market. So to illustrate this, we just churn a lot of data. So basically everything that influences supply and demand in some way. This is a lot of weather data, a lot of physics data from the power system, and also real-time connections to the power markets. So whenever something new happens in the power markets, we will know it and we will adjust it. This goes into our foundation model. The reason why we do a foundation model and not forecast is that we want to represent uncertainty. That's our goal, right? And then once we have the representation of all of these different markets, we basically know the environment that a production asset can navigate in. But then we also need to know a bit, okay, what are the boundary conditions and what's the objective? And those are basically shared with us from a customer. And here, because every asset is unique, a battery has a very good alternative cost because it can just produce the next day. A wind power producer, they must be sure that they close an imbalance. So their risk profile will be very different, and they will accept different prices as being good prices, right? We consider this in the multi-market optimization. So basically, any asset can get a risk-adjusted optimal strategy in real time because we always update whatever happens in the market and just get it directly for them to submit to a power exchange. We have been quite successful. It's very easy to use. It's very computational heavy, but we do all of that computation on our side, right? We handle the GPUs and the data connections and all of this. We handle the multi-market optimization. And then they can just connect to either a web app or a graphical user interface and do all of this advanced optimization. We have several of the largest Norwegian power producers as users, despite the company just being 2.5 years old. We recently launched in Norway long time ago, but Denmark, Sweden, and Germany. And basically now we're going fully into Germany and having the customer calls there. So, if this is interesting, if you have power assets, you want to see how can we do this better, please get in touch. Thank you.
Jeg fikk høre at etter klokken 3 kunne være på norsk, så det var det jeg forberedte. So to the English-speaking people, I'm sorry, but I know with AI you can translate me easily later. So sorry about that. Hallo alle sammen, mitt navn Thomas. Jeg jobber som forretningsutvikler I Qubit, og vi bygger den digitale infrastrukturen I energimarkedet. Mange kommer til å si de har løsningen. Men vi mener virkelig vi har løsningen. På grunn av at ikke bare kan den svare på dagens kraftutfordringer, men fordi vi har den viktigste kraften av de alle I teamet, nemlig gjennomføringskraft. Yes. Så hva problemet? Vi mener I henhold til kraftmarkedet så står vi overfor 2 av de største problemene. Det ene klimakrisen, som krever en rask overgang til ren energi, og den andre den økte etterspørselen som kommer av strøm, spesielt I forhold til det som temaet AI. Vi mener at vi bak målene våre, og vi vet at bygninger mer enn halve problemet. Og flaskehalsen vår, det strømnettet. Det tar for lang tid å oppgradere og bygge et nytt strømnett, og det vil til syvende og sist ikke være bærekraftig. Dette sikkert tall dere kjenner godt til fra før, men jeg velger å vise det likevel. Jeg har jobbet på markedsføring, så jeg liker å poengtere et budskap mange ganger. Yes, 40% bygninger står for 40% av verdens globale CO2-utslipp. Det ganske mye. Og på grunn av begrensninger I strømnettet, så blir 20-30% av fornybar energi I bygninger redusert på grunn av håndteringsproblemer. Det ønsker vi I Qubit å gjøre noe med. Derfor har vi utviklet en skybasert programvare som skal gjøre bygninger smarte og dynamiske. Den optimaliserer energi ved å analysere historisk data og forutsi forbruk. Ikke bare det, den skal også kunne forecaste hvor mye etterspørselen kommer til å være, ikke bare 24 timer frem I tid, men 48 timer frem I tid, slik at du som en byggherre eller driftssjef skal kunne reagere in real time og ta en god, informert beslutning. Men teknologien vår den stopper ikke bare her. Vi skaper et nettverk av bygninger som kommuniserer og interagerer med hverandre gjennom vår software og fungerer dermed som en desentralisert microgrid, hvor alt kommer til å være automatisert og optimalisert programmatisk. Og det som kanskje kickeren at vår løsning vil kjøpe energi når prisene lave, og selge det tilbake til nettet når prisene høye. På denne måten så bidrar vi også til å balansere strømnettet. Vi trenger å få bygninger med I fleksibilitetsmarkedet, ikke bare for at bygninger skal kunne spare energi, men for at de skal kunne tjene på å være aktive bidragsytere I et energimarked. Men for at vi skal kunne levere merverdi til kundene våre, så trenger vi jo riktig mengde data. Dette kanskje en av de kuleste pilotene som vi har så langt. Dette en pilotprosjekt vi har med fagene. En liten øy på Utsira, vest for Norge, hvor det bor cirka 200 mennesker, og det 70 bygninger. Her ønsker vi å bygge et uavhengig... Hører dere? Ok. Her ønsker vi å bygge et uavhengig kraftsystem som både støtter samfunnet og balanserer strømnettet. Som dere kan se på bildet her, så denne øya driftet av en kabel som tar opp til 2 megawatt kapasitet, og vi ønsker å gjøre denne øya uavhengig av denne. Og når vi har rett data, da kan vi begynne å finne forbruksmønstre. Da kan vi kartlegge daglig, ukentlig og månedlige forbruksmønstre, og finne de energitoppene når alle drikker kaffen sin samtidig, for eksempel. Vi gir sanntidsanalyse for å kutte kostnader og optimalisere forbruk. Prediktiv analyse gjør at kundene våre kan jobbe mer proaktivt mot svingende energipriser. Med Qubit så skal du ved å finne og gi prognoser på når og hvor flaskehalsene oppstår, redusere energitap og forbedre påliteligheten. Reaktiv effekt, det snakker vi mye om i strømnettet, og også noe vi skal optimalisere. Reaktiv effekt at energien som trengs for å holde strømmen jevn i nettet. Så, vi har jo vært litt i... Her mangler vi en slide, ja. Beklager. Hva sa du? Neida, det går bra. Dette flere av pilotkundene våre i dag. Amfi Moa, Ski Storsenter, Strømmen Storsenter. Dette veldig store bygg, og alle sier at de har akkurat det samme problemet. De skulle gjerne kunne forecaste hvor mye energi de kommer til å bruke de neste 24, de neste 48 timene, slik at de kan ta en beslutning, og for eksempel finne ut av, ok, hvordan skal jeg reagere på eksterne faktorer som vær? Da ønsker jeg å få en pling i innboksen min gjennom vårt system, som kommer med et forslag til Ole, som for eksempel driftssjef i Strømmen Storsenter. I morgen så vil det være en temperatur på 15 grader og full sol klokka 1. Her skal du få noen forslag til hvordan du kan energioptimalisere bygget ditt. Der, ja. Og da kan Ole ved hjelp av et enkelt ja få forslag til tiltak han kan gjøre for å energioptimalisere bygget sitt. Da får han forslag til ulike tiltak på høyresiden, og han kan enkelt trykke på disse for å gjennomføre tiltakene. Så vil han også på slutten av chatten som du ser til høyre, se hvor mye han kommer til å spare på å gjennomføre disse tiltakene. Men for å ta en sånn system ut i markedet, så trengs det et team bak alt sammen. Og det oss her. Vi har en bakgrunn fra både salg, markedsføring og tech, og ikke minst en CEO som virkelig har en visjon, som jeg trodde på, og det var derfor jeg ville bli med på det her. Ikke minst så kaster han meg ut foran dere etter at jeg har vært der i 2 måneder. Så det lærer jeg også veldig mye av. Så tusen takk for at jeg fikk lov til å fremføre for dere i dag, og la oss møte fremtidens kraftutfordringer med den viktigste kraften av alle, gjennomføringskraft. Takk for meg.
Hi, my name is Bielenis. I am CEO and co-founder of Soren, Sorfar for renewable hydrogen, which is our main focus. And we have managed to actually simplify and capture in a very streamlined process how decision is made financially to which hydrogen projects should go ahead or not. This is the software that, according to our users, is their #1 choice when they're trying to evaluate different projects within green hydrogen. We are a Norwegian company backed by venture capital, 3 from Norway and 3 from Spain, as well as funding from the Norwegian government and other institutions. So I really wanted to angle the conversation around AI, which is the topic. Why green hydrogen? I get that question a lot, and I think we could talk about it in detail, but I think #1 is, as we've learned today, the global energy demand is on the rise, influenced by AI, of course. So the energy need from data centers is on the rise. What many don't know today is that, for example, in the US, where you have most of the data centers today, 2% of the total electricity consumption in the US comes from data centers. But one query to AI takes actually between 10 or 100 times the same query to do in Google. So it is quite intensive, the demand, and also even though there will be efficiencies to be gained, the queries will also become more complex in these more advanced language models. And also that many of these centers today, as green as we want to say that we want them to be, most of them use diesel as a backup fuel. And it's not in small amounts of diesel. I'm a petroleum engineer, actually by education, transformed into the green transition. And yeah, so it is quite a lot of diesel being used. The reason, because of reliability. So we all want to be green, but there is a very important point on capturing and managing the energy that comes from the fluctuating, of course, renewable sources. And number 3, domestic energy security is the priority. Somebody showed the energy trilemma, which is great. Right before we started the company, it was a lot of focus on sustainability. But since 2022, the focus is very much on energy security at whatever cost, at whatever carbon footprint, just to be completely honest. So where green hydrogen goes in there? It is the only, and we can discuss that, clean alternative for industry that cannot be electrified. I'm talking about heavy industry, steel manufacturing, shipping, aviation, mostly long fuel, long haul, and fertilizers. Why is this important? It can be a backup also for the fuel that data centers will need, fueled by AI. And if we believe that what we want these data centers to be located in Norway, I think that it's important to think long term. The decisions to build a green hydrogen plant or a nuclear plant or anything that will be new energy, it will be seen in the next 10 to 20 years, which is really important that we keep that long-term horizon. And that's what we're helping the developers with. So simplifying the very heavy industrial process of producing green hydrogen. What it is basically renewables and water going through an equipment called an electrolyzer, and then you produce this green hydrogen and also oxygen, of course, from the water molecule. So what we have done is to put all of that process into a software that literally hands-hold the user to understanding the electricity profile, which electrolyzer to use, which balance of plant, and at which cost. So we have a cost information for all of this equipment so that we can provide to them the famous levelized cost of hydrogen, among other financial metrics. So with a background within energy advisory, I was a partner at Restart Energy. I understand very well how decision is made and what type of sources are used in forecast and so on. And I think it's really important to simplify these complex processes for the business decision makers. It is true, we all use complex electricity and concepts without understanding them, but the more we understand them, the better decisions we can make. So what does it mean in terms of cost? It's around 80% cost savings within the feasibility part of the projects, which is at the very beginning. And it includes, of course, intuitive interface, text and cost data, what I have mentioned. Something that's really important to clarify is that the user sees this super nice intuitive interface that is designed to be used by no-code analysts. So anybody who doesn't code can use it, but behind that is like a layer where you have thermodynamics and Python that is able to compute quite a lot of data in a small amount of time, a backend infrastructure, electrolyzers data, and cost data. Yeah. So we started just with the technical part of the electrolyzer, but the developers and the market has forces in a way to also model the solar, the wind, the CO2 certification of how much carbon is in the grid connection, and together with all the other parameters to be able to model a full cycle project within 30 minutes, really. This is some of the most common use cases, but yeah, this is one that was really good, located in Brazil, where the user could, let's say they wanted to use Nel or consider Nel from Norway as one of the providers of the equipment, and then we're able to provide to them, okay, these are a preliminary understanding of the Nel model, and then they can cross-check with what different providers are giving to them. Then they can say, okay, which one is within the market and the ranges that they want, and also to compare different locations. So this one's again from Brazil, and then you can compare the same plant configuration where you will get a higher MPV depending on where it's located. So this is some of the work. This is some of the results when you do the computational and the financial analysis in the model. It's very well documented and very, of course, easy to use. And it's of course, very reliable. So our data is stored in Norway, and I think that is in Europe. So I think it's good on that. We partner with electrolyzer manufacturers, and our clients are mostly developers actually outside of Norway. So still looking forward to working with more Norwegian companies on these who have these long-term horizons and an understanding of the importance of developing this. So yeah, some numbers, yeah, more than 150 electrolyzer manufacturers that we have relationship with, and yeah, just a lot of really good momentum in this space. So that's it. Thank you.
Thank you so much.